We are going to talk about indexing this week. I am Kendra Little, the founder of SQL Workbooks, and also these days I am an evangelist for Redgate Software. I have just started that job, and it is super interesting and fun getting to learn all the Redgate products and also talk to people about Redgate. But today we are not talking about Redgate at all. We are talking about indexes, and specifically, we are talking about a world of indexes that is classically really useful. And there are some announcements at Ignite. Microsoft is having their Ignite conference this week. It started this morning, and some of the improvements in the next version of SQL Server are for these row store indexes. So not only are these really classically useful and a great tool in SQL Server that we've had for years, but they're actually becoming even more powerful because a new feature called batch mode for row store indexes has been officially announced for SQL Server 2019. And we will get to a point this week where we get to talk about those. Now that is for SQL Server 2019. I'm going to show you some cheats you can use to actually use that fresh new feature in earlier versions of SQL Server. But what are row store indexes? Well, row store indexes are disk-based indexes that we can create on tables in SQL Server to speed up our queries. And not everything you see on this map here is an index. So for instance, on this map, I do have a heap here. Now a heap is if we have a table and we don't create a clustered index on it. If we have a disk-based row store table, that is, the data is aligned in rows, not in columns, and we choose not to order the data on the table, it will simply be a heap. So that is just a table that doesn't have a clustered index on it. We can order the data on that table with a clustered index. A clustered index is the table itself, and we define one or more columns that is going to physically sort those rows on disk. So we're saying, yeah, I've got this whole row of data, but I'm going to specify one or more columns that I want you to order by this column. Alphabetize it if it's alphanumeric data, but order, sequentially if it's numeric data. I want you to order the table by the columns that I specify, and then just keep everything else in the row together on it. We can also create non-clustered row store indexes. These are secondary structures we create. They aren't the data itself. They're a copy of the columns we specify in the non-clustered index. And you can actually create a non-clustered index. You could create it on a table where you haven't ordered the data in the table. You could create it on a heap, or you could create it on a table where you've ordered the data in a clustered index. You can only ever have one clustered index per table. I mean, you could have zero, right? If we have zero clustered indexes on a table, we have a heap. If we have one clustered index on a table, we have a clustered table. But we cannot have more than one clustered index because it is the table itself. We could create, if we wanted, we could create a non-clustered index that had all of the columns in the table in one way or another. That would be a copy of the table, but it would still, SQL Server would still know, hey, this is a non-clustered index. This is a copy of the data. The table itself is over there. The table itself is either a clustered index or it's a heap. We can also get kind of fancy with these row store disk-based indexes, and we're going to look at this either today or tomorrow as well. We can create non-clustered indexes that have filters on them that only contain a subset of the rows. And we can get fancy and we can create indexed views. This is a view that is persisted to disk that is automatically updated along with the table. And these can be really, really cool for performance. There can be some gotchas, both with the filtered non-clustered indexes and with the index views. So we're going to talk about how these can be really, really cool and really worth doing, but you have to be careful with them and just make sure that you know what these gotchas are so that you can avoid them and get all of the good parts of it without falling into the pitfalls of it. But these row store indexes they've been with us a long time to help us tune performance in SQL Server, and they're still incredibly useful. We now do have lots and lots of different tools in SQL Server. We've got Hecaton, otherwise known as in-memory OLTP. Basically, we've got these kind of fancy planets in the galaxy of indexes now. We've also got column store indexes that order data in a columnar fashion, and these even can have clustered column store on them. The table itself can now be stored in a columnar fashion. We can also create, we can mix our planets together. We can do things like have a clustered index on a row store table. So have a disk-based clustered index, and column store, by the way, is also disk-based unless we mix it with in-memory OLTP and get really crazy. We could have a disk-based clustered index. The table is row store, everything's aligned by rows and is disk-based, and we could put a non-clustered column store index on that. So it is possible to mix and match among these planets and go around in your rocket ship. But the truth is that, yeah, these new features of in-memory OLTP and column store index, they can be really good for specialized situations. So for instance, with column store, let's say that I need to scan a lot of data all the time. And for columns of data, I either am going to scan every row in that table, or I have a massive table and I want to just scan some partitions of it. I know I can get partition elimination with table partitioning. Column store indexes, because they compress columns together, they are great for those situations when you need to scan lots of data. But a lot of times we don't want to necessarily scan an entire partition or an entire table. We may want to look up individual rows, or we may want to do a seek and do sort of a partial scan of just certain values. In fact, that's going to be a lot of the time for us. And that's why we still primarily live in this row store world. It is still, even though we have these new kind of indexes, we primarily live in a row store world, and we're going to bring in column store indexes for specialized situations and for a lot of things like data warehousing. We do increasingly have these mixed workloads on servers where we've got some warehousing mixed in with some OLTP. We may mix it into those workloads, but it's much more of a specialized tool, especially now that we officially have, and we are going to look into this more, there's a feature that was introduced with column store called batch mode processing that is the ability for SQL Server to not just go 1Z, 2Z, 3Z, but hey, I want to deal with hundreds of values on the core at the same time. Instead of my physical processor cores looking at 1Z, 2Z, 3Z rows, I want it to look at a whole batch of rows at the same time. Now, a batch of 900 rows, it could be useful to process a batch of 900 rows, even if I'm not going to scan the whole table. Even maybe I'm scanning 10,000 rows. Hey, it would still be useful to do this batching. And now in SQL Server 2019, and we do have ways to hack this in. It's unsupported, but we have ways to do this in earlier versions as well. This batch mode processing is now being given to us for row store indexes as well, because the ability to process a batch of rows on your processor core can work really well with row store too. So our home of row store indexes is, in fact, just getting better than ever. And that doesn't mean these other indexes are irrelevant. It really just means we want them for specialized situation. But the cool thing about this place where we live with the row store indexes is these are available to us in every edition of SQL Server. They don't cost a lot of extra money. Now, there is a little bit of a gotcha with index views. Some features with indexed views are only available in expensive edition, but you can actually use them really, really well in standard edition and the lower editions too. It's a pretty minimal limitation, and we will go through that. So, there's always an exception, right? But most of the, almost 99% of the row store world, we can use in every single edition, and it really helps us scale things without paying extra money. So this is what we're focusing on in this seminar, because it really makes sense for scalability reasons to understand deeply these principles of what can I really get with row store indexes and get everything we can out of those before we use some of the more expensive indexes. Now, as of SQL Server 2016 Service Pack 1, we are able to use some of these more specialized indexes in, quote, lower editions. What I'm saying is, in things other than enterprise, developer, and evaluation editions, right? But they are limited in terms of the number of resources you can use for them. So I think that's a great thing that now we can start to use column store indexes and Hackathon in non-enterprise editions. However, we are capped in terms of the amount of memory we can use for them or the amount of CPUs. It varies by feature. And it's all laid out on, there is a great blog post for SQL Server 2016 SP1 that kind of explains the different caps for all of those. But it still makes sense to get everything we can out of row store indexes. So what we are going to do in these 2 sessions, today and tomorrow, is that we are going to go through and talk through first non-clustered indexes, because non-clustered indexes are, I think, the easiest way to kind of learn about the structure of indexes and how they work. We will also talk about strategizing index tuning. When we see with the dynamic management views recommendations about index tuning, what does that mean? We'll talk about tuning indexes with Query Store, and we will talk some about clustered index design as well. When we're talking about indexing, we're talking about essentially the art of guessing what will the SQL Server optimizer do in a different situation. And this is a really important thing to guess, and it's a really fun thing to guess because you learn a lot about how query optimization works in SQL Server when you are learning about indexing. So we are going to be learning a lot about execution plans and query optimization today and tomorrow as well. And we are going to do this by stepping through a series of problems. I like to do this with indexing because that's how I learned about indexing myself. I went through just different query performance problems and had to ask myself, could I speed this up with an index? And I guessed at different ways to get it to work and got to figure out why. So that's what we're doing today. And I really encourage you to guess. So basically, there's 2 problem types. Today, we are mostly going to be doing performance-based design problems. Tomorrow, we will do some strategy problems. I promise it will be easy once we see them to figure out which question is which type. All right, well, we've already had some interaction in the Slack channel. Please do continue to let me know if my microphone stops working, hopefully. Hopefully that doesn't happen again. We will take some regular breaks. Feel free to ask questions at any time. It helps others when you ask questions. And recordings will be posted as soon as they are available. I'll try to edit out all of the silences when my microphone stopped working to make the recording better. So let's go ahead and get started with our first problem there.